Today we're going to learn how to multiply polynomials. Now we're going to start with a real basic format where we're multiplying a monomial or a single term polynomial by a larger polynomial. In this case, we're using our basic distributive property that we've used for several chapters now. We're just going to remember to apply our exponent rules. So remember that when I multiply 2x cubed by x cubed, I multiply my coefficients, 2 times 1, which is 2, and x cubed times x cubed. When I'm multiplying two numbers with the same base, I add the exponents, get x to the 6th. So then when I multiply by 3x squared, I multiply the coefficients, 2 times 3 gives me 6, and I add the exponents of my x to get x to the 5th. 2x cubed times negative 2x is going to give me a negative 4x to the 4th because that has an invisible 1 exponent. And 2x cubed times 5 is going to bring me up to 10x cubed. So that's just basic distributive property. But when we have multiple terms in both polynomials that we're adding together, the distributive property gets a little more complicated. Essentially, we have to look at it as this x needs to be distributed over the 3x and the 2, and x times 3x is 3x squared, and x times 2 is 2x. But I also need to distribute the negative 4 over the 3x and the 2. Negative 4 times 3x gives me negative 12x, and negative 4 times 2 gives me negative 8. My last step is to simply add like terms, and I get 3x squared minus 10x minus 8, because those two combine to be negative 10x. You may hear this process called Foyle, and it stands for firsts, which refers to the first term in each, which I multiply together. Then the outsides, which is the two outside terms that I multiply together. So that was 3x squared and then 2x. The I stands for inside, which is the two inside terms here. Those multiplied together gave me the negative 12x. And the L stands for last, which gave me the negative 8. Now we could do this in a vertical format if we like, just like we did with multiplication of big numbers when we were in elementary school. So if I have two polynomials and I want to multiply them vertically, well, I just start by rewriting them vertically, and I usually put the one with more terms on the top. And I approach it the same way I approach this type of multiplication in elementary school. I do negative 4 times negative 7 first, and negative 4 times negative 7 is positive 28. And I do negative 4 times 6b, which is negative 24b. And negative 4 times b squared, which is negative 4b squared. So that took care of the negative 4. Now when I move on to the next term, I go to the next line down and I leave a space. Now this is especially helpful because when I multiply 3b by negative 7, I get negative 21b. And so if I leave that open space, when I write negative 21b, it's right below the negative 24b, and so my like terms line up. 3b times 6b is a positive 18b squared. And 3b times b squared is 3b to the third. So now my like terms are all lined up, and I can just add them straight down. Negative 24b and negative 21b together make negative 45b. Negative 4b squared and positive 18b squared together make positive 14b squared. And the 3b cubed gets brought down as well. So there's my final product. So we can multiply them horizontally, like we did back here, or we can multiply them vertically. Why don't you try one on your own? 3a plus 4 times a minus 2. Give that a shot and see what you come up with. Alright, so if you were careful, here's what we would have come up with. 3a times a is 3a squared. 3a times negative 2 is negative 6a. 4 times a is 4a. 4 times negative 2 is negative 8. So adding my two like terms brings me up to 3a squared minus 2a minus 8. Now you may have done it vertically, or you might have multiplied in a slightly different order, but as long as we came out with the same thing, then we're good. Now we can use this in word problems when we want to use a variable to represent something we don't know. For instance, the dimensions of a rectangle are x plus 2 and x plus 3. What is the area of a rectangle? Well, we know that when we have a rectangle, to find its area, we just multiply its two dimensions, its length and width, together. So that's what we're going to do. X plus 3 times x plus 2. I'm going to do this one vertically just to recover that method. 2 times 3 is 6, and 2 times x is 2x. X times 3 is 3x, and x times x is x squared. So adding my like terms gives me a total of x squared plus 5x plus 6. There's my area. Now, this might be helpful in the following problem. If we look at example 7 in the book, it says you're designing a rectangular skateboard park on a lot that is on the corner of a city block. The park will have a walkway along two sides. The dimension of the lot and the walkway are given. So we have a rectangular lot that has a walkway built into it, like so. Now, the total width is 45, total length is 33, and the width of the walkway all the way around is x feet. So we want to write a polynomial that represents the area of the skateboard park. Well, that's this region in here. Now, its width is not a total of 45. It's actually 45 minus x, because it's not all the way across. It's all the way across that's 45, but the skateboarded park is only this section here. So we have to take that x off to get the width of our skateboard park. Similarly, our length is 33 minus x. We have to take off that portion at the top there from our 33. So our area is 45 minus x times 33 minus x. So if we multiply these together, 45 times 33 is 1,485. 45 times negative x is negative 45x. Negative x times 33 is negative 33x. And negative x times negative x is positive x squared. So we have a total area of 1,485 minus 78x, that's what I get when I add my like terms, plus x squared. So there's the polynomial that represents the area. Then they want us to find the area of the park if the walkway is 3 feet wide. Well, since x represents the width of the walkway, all I have to do is plug in that 3 feet for x. So I have 1,485 minus 78 times 3, which is 234, plus 9. Totaling that up, I get a final area of 1,260 square feet. All right, if you have any questions, feel free to ask. If not, you can move on to your homework.